Welcome, everyone, and thank you for joining today's virtual conference. My name is Frazier Martins, and I'm your host for today. Now, as big data cements its foothold in business strategy formation, data storage solutions such as data lakes are quickly becoming cornerstones in driving business value. Yet, this value is truly realized only when insights can be derived from the data stored for proactive decision making. This goes beyond just analytics. The intelligent data lake on GCP contains data from various sources over the long term. This enables companies to organize, analyze, and activate data centrally via marketing channels without having their own hardware or data center. With this context, Dun& Bradstreet, in collaboration with Niveus Solutions and Google Cloud, is pleased to host this virtual event titled Going Beyond Data Analytics with Intelligent Data Lakes. Now, before we begin, I request everyone to please take a moment and go through the guidelines that have been displayed on your screens. We encourage you to ask more questions in the session, and we request you to please type your queries in the Ask Questions section. These will be taken up in the Q&A session later. A couple of tips, though. We want to know you more, so please mention your name and company name when you post your question. You can also mention the person you are directing your question to. As you can see on your screens, there is an Ask Questions section at the bottom of your screen that will help you converse better with our speakers. Now, let's take a quick look at the flow for today's session, and for that, please refer to the agenda displayed on your screens right now. A promising agenda with an eminent lineup of speakers. I would like to take this opportunity to welcome and thank everyone for being a part of this virtual session today. Without further ado, let's kickstart then with the opening speaker of the day. I would like to invite Ms. Kirthi Ganapathy, Customer Engineering Leader, Google Cloud, to share her insights with us. Ms. Ganapathy is a highly driven and organized professional with over 20 years of experience in solution architecture and design, consulting and professional services in data, artificial intelligence, and cloud across BFSI, telecom, and retail, coupled with excellent communication skills, analytic skills, proven team building, and leadership abilities. Welcome, Ms. Ganapathy. Over to you.
Thank you so much, Frazier. I would request Aditya to go ahead and share the slides, please. Yeah, thank you. Thank you so much. Thank you so much, Aditya there. So good afternoon, good evening, everyone. My name is Kirthi Ganapathy, and I lead a team of data and analytics specialists at Google Cloud India. My team and I partner with customers to help them get started and progress on their digital transformation journey with the right solutions based on their requirements. Over the last couple of years, we've had the privilege of working with a number of our customers who've embarked on this digital transformation journey. And of course, data is at the forefront of this journey. Now, we've been fortunate enough to get the opportunity to partner with some of our clients on this path and help them innovate with data and analytics for better insights and outcomes. Now, if we were to look at customer requirements today, most would agree that irrespective of the industry they belong to, at the forefront of everything is their ability to provide a better experience to their customers, right? While this is very obviously true for consumer-focused industries such as retail, financial services, media and entertainment, etc., others like manufacturing are equally driven by consumer needs. When I say better experience, it includes a better understanding of the end consumers, be it demographics or their preferences, and of course, an improved ability to pitch the right products to the right consumers. To all of this, there is also an industry flavor that gets added, which obviously aids and adds to the better experience of consumers. For instance, the retail industry is focused on areas such as pricing their products right and ensuring availability of the right products to the right stores, ensuring their customers get personalized recommendations, whether in store or online. Financial services organizations, apart from improved customer experience, are also focused on things like fraud detection and prevention, and obviously want to avoid the associated heavy fines as well that result from data breaches. The public sector, on the other hand, is focused on providing better services for citizens, be it better management of transport or better management of natural disasters and pandemics like the one we're still going through. Media and entertainment, which was booming during the pandemic, faced a whole bunch of different challenges, right? From ensuring a constant stream of good digital content to the right content classification to providing the right regional language processing and translations as well, right? So operationalizing all of these use cases essentially requires data to be made available to the right stakeholders at the right time in the right manner. And here is where intelligent analytics comes in. Moving on. So today, if you look at statistics today, you will see that we are living in a world where data is not only growing at a staggering pace, but is also increasingly distributed. Right? Teams want the flexibility to pick the technology of their choice to build applications. And this means that data often ends up being spread across different types of storage systems, different clouds, different formats, and of course, different regions as well. Yet, at the same time, this data has a lot of analytic value and is increasingly needed to serve the ever-growing set of use cases for every industry that I spoke about, ranging right from data warehousing, business intelligence, operational reports, artificial intelligence, better customer recommendations, customer personalization, data power applications, etc., and more. Moving on. Now, if you see, this has actually created a value gap between what businesses need and how technologies have evolved. If you were to look at the situation 20 years ago, we lived in the world of on-prem data warehouses, where the prevalent wisdom was to bring all data together for analysis. As data volumes grew, this was no longer feasible because data volumes were just increasing and technology was not really able to keep pace with it, right? And object stores then had to evolve into data lakes, and HDF has actually paved way into big data processing. Over time, what happened is all of this ended up creating a data silo. If we were to look at the next slide now, let's look at why have these data silos come up and why are they so difficult to manage, right? Now, these data silos primarily exist because data warehouses and data lakes have two different stacks to manage data, two different methods or two different formats of managing data. Data warehouses manage the data using their own storage and their own formats. Whereas if you look at data lakes, they rely on open formats primarily and tools stitched together to manage this data. There is a vast difference in the capabilities as well. For example, data lakes don't always offer row columns level security or performant queries as well. As a result of which, we see customers building infrastructure to move and manage two copies of data. So data lakes are primarily being used for one set of use cases, whereas warehouses are still serving the old set of operational use cases, right? Now, with the growth of data and use cases, this approach, what we've seen is increasingly becoming non-scalable. Moving on. Now, if you look at the need of the hour, in 2022, or what is the analytics of the future, right? So modern day analytics requires making sense of distributed data and enable a range of use cases across all of this in a secure and governed manner, which means that we first need to solve the problem of data silos. Moving on to the next slide. A few years ago, when I was called upon to assess the data maturity of an organization in the financial services sector, the problems of the IT team were mainly about they did not know what kind of data they had. There were different systems, but they were unaware of the sanctity of data in each of these systems. Their end users did not trust the information that the IT gave them. There were different reports that were created, but questions around the data and where it was coming from remained. Many source systems captured the same data and they did not have a single source of truth. For instance, different sources captured the same customer data. And a lot of times when the data in one source was updated, was it actually updated in the others? Probably not. But more than that, they had no idea about the same. Other sources had missing or incomplete data. They were not sure if their data was really secure because everyone had access to everything, and worse, anyone could edit anything. And finally, the data was all in different formats. At that point of time, the solution was simple, right? Build a central data warehouse with an underlying data governance layer. Everyone gets data from this warehouse, and the data is now trusted. At some point, the organization would obviously have to also go back and fix its processes and its overall source systems as well, and train its people to embrace data governance. So now we're talking about a single solution to cater to all of these problems. Now imagine the situation today. Most organizations actually went ahead and implemented all these suggestions from all those years ago and created data warehouses, some cases data lakes, data marts, and of course, they still have their source systems, which are mostly on-premise data centers, which are still feeding to a lot of these data lakes and data marts. Now, with the advent of cloud, some organizations decided to take advantage of the scalability, manageability, and all other advantages that cloud provides and move their data to cloud. And then, of course, there were some others who decided that cloud B does better in analytics than cloud A. So let me run some analytics in cloud B, thus leading to diverse data solos, some on-prem and some on multiple clouds as well. And each of these systems obviously has its own way to handle metadata, security, and governance. For many of our customers, this is an operational nightmare that begs to be resolved. Now, if we look at the next slide, let's talk a little more about what you can do to actually break down these silos, right? So this is where an open and an intelligent data platform comes into play. Now, what is meant by intelligent? Now, we have completely serverless, self-optimizing architectures today that can scale as per our customers' needs. And when we talk about data, the ability to automatically understand and classify data becomes important as well. And when we democratize machine learning by letting SQL practitioners build machine learning models using existing SQL tools and skills, it takes away a lot of overhead, both in terms of operational overhead as well as cost overhead, right? And when we talk about simplified, we already spoke about eliminating a lot of operational overhead, right? With our intelligent ways to embed analytics into everything you do. We have simplified this further by supporting all types of data assets that span multiple environments across on-premise data centers, across cloud platforms, data assets of a variety of data modalities, be it structured, semi-structured, unstructured, data at rest, or streaming data, right? And then data that is raw or curated, data that is standardized, or data that has been brought in for experimentation as part of innovation cycles. For instance, it could be a data set, a file, an Excel report, a data element, or even a stream of data objects, right? And when we talk about reliability, as far as reliability is concerned, there should be no doubt whatsoever in anyone's minds on Google Cloud Platform, with the industry's best reliability at 99.99% SLA and the ability to scale to petabytes. BigQuery, which is our analytical solution, is by far the best reliable analytics solution out there. Now, let me move on to the next slide. Now, Google Cloud brings all of these capabilities together as part of its unified data platform, at the center of which lies Big Lake that we announced a couple of months back. Built on years of investment in BigQuery, Big Lake allows organizations to unify data warehouses and lakes and enable them to perform uniform, fine-grained access control and accelerate query performance across multi-cloud storage and open formats. For instance, you may have different databases which are using different formats. You may have a data warehouse which uses a different format. Big Lake actually allows you to create something called big tables, right? And so essentially you can use this to actually perform all of your analytic queries on one system itself. So Big Lake essentially helps you unlock the full potential of your data by breaking down data silos and enabling data on warehouses and lakes be uniformly accessible to whether it is to Google Cloud or whether it is to other open source query engines, right? So customers can create Big Lake tables on Google Cloud Storage, Amazon S3, or even Azure Data Lake Storage over supported open file formats such as Parquet, ORC, and Avro. Big Lake tables are a new type of external tables that can be managed similar to any data warehouse table. Administrators do not need to grant end users specific access to files and object storage, but instead manage access at a table row or column level. These tables can be created from a query engine of your choice, such as BigQuery or any other open source engine using a Big Lake connector. Once these tables are created, Big Lake and BigQuery tables can be centrally discovered in the data catalog and managed at scale using what we call Dataplex. I will be talking more about Dataplex in some of the subsequent slides. So what Big Lake also does is extend the BigQuery storage API to object stores to help you build a multi-compute architecture. Big Lake connectors are built on BigQuery storage API and enable other services like Google Cloud Dataflow and open source query engines such as Spark, Trino, Presto, Hive, etc., to be able to query Big Lake tables by enforcing security as well. So this actually eliminates the need for you to move data to different query specific, depending on your use cases. It actually, you do not need to move your data to different storage systems, right? So that's essentially the advantage that Big Lake brings in here. Right, so security and access control again is uniformly enforced and can be centrally managed with Dataplex. Now, I will speak about Dataplex, more about Dataplex in the subsequent slide. Now, if you look at the next slide, we'll talk about some of the use cases for Big Lake. Right, so when we had launched Big Lake about a month or so back, we had a preview first, right? So during the preview, we saw a large number of customers actually use Big Lake in different ways. So here I'm just going to talk about or touch upon some of these use cases, right? So the first one was building secure and governed data lakes for open source workloads. So whether you're migrating from Hadoop, Spark, or those using Presto, Trino, etc., can now use Big Lake to build secure, governed, and performant data lakes on Google Cloud Storage. Big Lake tables on Google Cloud Storage also provide, like I already mentioned, right, fine-grained security, table management, better query performance, and integrated governance as well. So these characteristics, again, are accessible across multiple open source query engines by using the Big Lake connectors. Right, and we've had a lot of customers even coming up to us. They used all these capabilities during the preview, and they came up and gave us suggestions as to what we could do to improve. So we've incorporated a lot of those improvements as well. Right, the next one would be eliminating or reduce data duplications across data warehouses and data lakes. So customers who use both GCS and BigQuery managed storage had to previously create 2 copies of data to support using BigQuery and OSS engines as well. Now, what Big Lake does is basically makes the GCS tables more consistent with BigQuery tables, reducing the need to thus duplicate data. So now customers can actually keep a single copy of the data split across BigQuery storage and GCS, and data can be accessed by BigQuery or the open source engines directly in either places in a consistent, secure manner again. Now, let me talk about security again. So if you look at fine-grained security again for multi-cloud use cases, BigQuery Omni customers can now use Big Lake tables on Amazon or Azure Data Lake as well, and configure security in a consistent manner across all of these different data lakes and data warehouses. Right, and similarly, tables created on each of those different data lakes are also accessible using a single control pane. So these are some ways again, by which you're saving a lot of operational overhead. You don't have to move data from one place to another as well. Right, then the whole interoperability between AI and analytics, right? So data science workloads, whether you're using Spark or Vertex AI notebooks, you can now directly access this data again via BigQuery or Google Cloud Storage, again using an API connector. Here again, we're making sure security is enforced. Again, you don't have to import data for your model training needs. Similarly, if you have heard, or if you're using BigQuery ML, which is again our embedded machine learning within BigQuery itself, if you're using that, again, you can import some of these models directly into BigQuery to produce your inferences or insights from the data. I'll move on to the next slide again. Here again, I've already spoken about most of these features here, so I'm not going to spend too much time on this. Just going to call out the performance acceleration here, right? So when I'm talking about performance acceleration, essentially what we are now going to be able to use is the underlying BigQuery infrastructure itself for executing some of these Big Lake queries. So as most of you might be aware, BigQuery is one of the best in class as far as performance is concerned, right? And if we are able to leverage that underlying infrastructure to actually be able to get better performant queries, well, why not? So that's the advantage that Big Lake additionally brings in. And of course, it's all built on open format, right? So today there is a lot of emphasis on how open your entire data infrastructure is, right? In case, again, it's not just about open. So since we are looking at a lot of multi-cloud use within our customers as well, so it's actually becomes important that the formats are open, so that if you have to actually move from one provider to another, there is not much of a problem there, right? So here again, when I talk about it's built on open formats, you can actually look at, this is actually built on some of the most open formats such as Parquet, Avro, ORC, CSV, JSON, etc. And similarly, multiple compute engines are served through Apache Arrow. Now, customers can also share Big Lake tables on Google Cloud Storage with their partners, vendors, and suppliers as linked data sets. So consumers can actually access all of this data in place wherever they want through their preferred query engines. Again, their preferred query engines could be BigQuery, it could be Spark, Presto, TensorFlow, etc. Now, let me move on to the next slide. Okay, so again, how this all comes together with Google Cloud and what are some of the Google Cloud technology that we are using here, right? So we already spoke about BigQuery extending to, BigQuery and BigLake coming together. Basically, we're creating BigLake tables here, so BigQuery customers can actually use all of this, whether it's on Google Cloud Storage, Amazon or Azure, and everything comes together seamlessly, right? And big lake tables are actually created using a cloud resource connection, which is a service identity wrapper that also enables governance capabilities. So administrators can manage access control for all of these tables, similar to BigQuery tables, right? So you don't have to specifically provide access differently for each of these tables. Then again, we already spoke about row level security, column level security, etc. Then again, I spoke about open technology and how all of this works, in a seamless manner with different open source technologies such as Spark, Presto, Trino, TensorFlow, etc. And similarly, data governance, a unified management layer or unified governance layer with the help of Dataplex. So Big Lake actually integrates with Dataplex to provide management at scale capabilities. So customers can actually organize data from BigQuery and GCS into lakes and zones that map into their data domains and can centrally manage policies for governing that data. These policies can then be uniformly enforced by Google Cloud and open source query engines. Dataplex also makes data management easier by automatically scanning Google Cloud Storage to register Big Lake table definitions in BigQuery. So remember when I spoke initially about it's also important to be able to understand your data automatically and make sure it is actually going into the right zone, right? So that is also something that can be done automatically, and all of these are available as part of a meta store as well. So if in case there are end users who want to discover some of these data lake tables for exploration and querying, they can do so again using whatever application of their choice, right? So if we look at all of these capabilities together, you are actually able to run multiple analytic runtimes over data spanning lakes and warehouses in a governed manner. This actually breaks down silos and significantly reduces the infrastructure management effort, helping you advance your analytics stack and unlock new use cases. Now, in the next slide, I'm just going to quickly touch upon Dataplex and where Dataplex fits into the whole architecture. Now, what is Dataplex? Dataplex is nothing but an intelligent data fabric that addresses most of the challenges that we spoke about earlier, right? So it enables organizations to centrally manage, monitor, and govern their data across data lakes, data warehouses, and data marts with consistent controls, providing access to trusted data and powering analytics at scale. Right, so Big Lake actually integrates with Dataplex to provide all of these at-scale capabilities. Right, now moving on to the next slide, where we will go a little deeper into Dataplex itself. So what does Dataplex offer you, right? So Dataplex offers unified metadata-led data management through a single pane of glass, centralized security and governance, enabling distributed ownership with global control, built-in data intelligence to unify distributed data without data movement, an open platform with support for open source tools, and a robust partner ecosystem. Now, if you look at the visual representation on the right, going from bottoms up, here we're speaking of data assets that span multiple environments across on-premise data centers, across cloud platforms, data assets of a variety of data modalities, again, like I spoke about earlier, so whether it's structured, whether it's semi-structured, unstructured, streaming data, etc., and different types of data assets, whether it's a data set, a file, Excel report, a data element, or a stream of data objects, right? So the data fabric actually helps the enterprise establish a logical organization of these data assets in terms of lakes, zones, and supporting unified management of these assets and enabling global governance and control with distributed ownership. So essentially what we're trying to do here is creating data as a service or data as an asset, right? And essentially the icing on the cake is the fully managed serverless data exploration experience over this unified fabric. Right now, if you look at some additional capabilities of Dataplex itself, now Dataplex, like I mentioned, helps build data lakes and zones depending on how your business is looking at data. Now, Dataplex further complements this by automatically registering the metadata as tables and file sets as metastores within the data catalog, consistent security policies across all your storage systems, which is out of the box, central governance. You can even audit what is happening here, okay, who is using what changes have occurred, etc. Additionally, with our integrated cloud data loss prevention API And built-in data quality checks, the capability to tag sensitive data is also tightly integrated. So this also meets your GDPR requirements, right? So this essentially also means that administrators can set up and manage different workspaces together with different profiles, compute parameters, libraries, etc. At the same time, they can also control user access and manage costs through one seamless interface, right? With Dataplex, data scientists also have one-click access to notebooks. Further, they can discover notebooks by using a notebook repository with links to associated data, while also being able to save and share notebooks as if they were sharing another asset within an organization, right? Similarly, data analysts can use SQL Workspace for any kind of ad hoc queries that they want to run or any ad hoc analysis without actually being dependent on any data processing environment. So effectively, through a single pane of glass, you can use Presto, Hive, or BigQuery without needing to access different environments. Last but not the least, data access is made simple and straightforward. An integrated experience across all of Google Cloud Data Analytics services provides a virtual lakehouse kind of an experience, right? So, and this is all complemented with an integrated serverless notebook experience with serverless Spark for data science. And all Google Cloud storage data is automatically made queryable through, again, open source tools or BigQuery. And you can actually, it also enables search and discovery across the board, across your entire set of data assets by using the data catalog, right? So here I was talking more around the technology and how Google Cloud is actually, bringing in newer and newer enhancements to its data cloud or Google Cloud Analytics portfolio, right? And it is actually evolving to cover the future of analytics as well. So now I would like to hand over to Aditya. And Aditya will speak to us about operationalizing some of these capabilities to be able to derive actionable insights from an organization's data assets, right? So Aditya is a techno-functional professional with over 6 years of work experience extensively in the data analytics domain as a data scientist and a data engineer. He has solved several critical business problems by devising methods based on data as a tool. He has transmuted several business requirements into technical solutions with his expertise. He has advanced knowledge in big data, supervised and unsupervised learning, AWS, GCP, ETL tools such as Talent and Data Stage, data warehousing, data modeling, and reporting tools. Over to you, Aditya.
Thanks, Kirthi. Thanks a lot. That was quite informationally rich content you have shared. So, hello everyone, and now I would like to start on how Niveus, when interacting with multiple customers, understood where the data maturity stages of when we try to assess the enterprises where they stand at a data maturity stages. So these all lie in one of the four stages. So first, generally they are when they are in a rear view mirror or in a reactive mode. So there is structured data that is transacted locally, and data is generally used reactively to see what has happened, understand what went right or what went wrong. Second piece to it was informative stage two, in which the structured data is centrally accessed, and now the business is informed on more of a near real-time basis instead of what has happened. Moving on to next, the stage 3 and stage 4 is now generally what we see all the organizations lie in and around in the predictive and a transformative stage. With the rise of IoT and a lot of greater enhancement in the data storage technologies, we can see the data capturing has compressively and scalably grown to petabytes and zettabytes. This we are storing on a daily basis. Along with that, the computation of this data, retrieving information from these pieces is what we can see on a predictive level, and then converting this value of data to a knowledge is what is today's businesses are focused on, the advanced analytics. The final stage is what we are at, and let look forward at into the horizon of the future is like any data from any source at anywhere can be computed with the help of the cloud technologies and the technologies we are going to mention about. Even before jumping to that, I just wanted to highlight the traditional data lakes, what we had, traditional warehouses. What challenges do this face, and what was the primary reason that it did not pan out so well as it was projected to be. So first piece to is it was open source. There were a lot of issues with open source. Open source technologies was very well accepted, but it did not cater to all the requirements which were presented by the enterprise. Also, it was not very easy to manage and scale all this open source technology, which came in from a varied source of resources that were available over the internet. Second piece to this was when we typically see a buildup of a data lake or data warehouse, it has a very long time to value to realize the monetary value or to realize the knowledge from the data from the day it start build on. That was immensely high. So sometimes it takes months to years to actually realize the complete value and understand how the transformation of building up the complete silo by silo data or complete integration of the silos phased out. Third piece to it was the data inconsistencies. Even after a data lake was built, a lot of structured, unstructured, semi-structured data was spilled across in puddles and ponds in a data lake. And that's where a lot of data inconsistencies were formed. There were a lot of issues with ACID transaction, which did not let to bloom the data lakes, on-prem data lake, especially to its full capacity. Next point to it was operationalizing the data pipelines. When I mean this, there was a lot of complex data pipelines with a hierarchy based to create a simple flows or extract value from the data. This increased in complexity required a lot of informed labor that used to handle this kind of operationalizing of the data pipelines. One of the other main point was metadata management. So as these data lakes, data warehouses started to scale up immensely, so managing of this metadata was a primary key concern of this, and it was not able to match up to the speed at which the data lakes were forming. For now, for instance, the data what we are trying to store and compute has already crossed the Moore's law to process and store data. So the management of data was a very critical piece in storing, and the success criteria of data lake, which did not went throughout, and a lot of issues were found when scalability of metadata management was to be mapped with respect to scalability of the data lakes. Last piece to it was data security and governance, which has been a primary pain point for a typical on-prem, because data security and governance was not they were not able to find one fits all solution to this piece, because the compliances, security, the governance regulations, a lot of things were evolving for different modules along the same data lake. So there were instances, different pieces or different module domains were growing apart along with the regulations and governance. So this all things led to a stop point or a clause or slowdown of a typical data lakes, what we have seen hierarchically, or today we have seen the implemented data lakes. These are the key pain points these are facing today. Uh, Now, what Kirti was very well mentioning about the value gap of the knowledge that we have analyzed or processed or obtained from the data that we have, and the amount of data that these days we are storing is nowhere near. And the game going forward would definitely be on analyzing or processing the existing data, converting the value of data into knowledge of already existing data. Sure, the data that will be growing, scalability will be growing in terms of pulling new data. That would be an added advantage, but existential data and processing upon it would be a key success to it. And like, how do we look at this to solve this problem? So if today we start to look at this as, if you want to develop the knowledge and meet the point to the data availability that we have in our lakes and ponds, so how do we do that? So 5 approaches we can to keys to take to this would be, we need to be structure agnostic. A lot of times when there is a primary use case of building solution around a data lake or data warehouse, what the generally people start with, they start as a primary thing, let's go with a semi-structured or structured data, and they primarily focus on a typical use case in terms of building things around it, instead of being really structure agnostic and use case agnostic, like building with respect to how it would logically pan out. Instead of that, they build around how the use case and structure or the different varied format that lies around the data. uh, Next piece to it is optimization of analytics cost. This can be easily solved from moving to cloud from on-prem. This was one of the prime concerns of on-prem data lakes. Another thing was scalability. With which ease cloud on a cloud we can data lake can be easily scalable. Is not with that ease on-prem we're able to scale out. So optimization of data performance was also one of the fine tuning of queries. Let's suppose say bucketing tables and different type of operational features to be maintained on this data was also needed, and that's how it can be easily tackled. It can be easily handled over a GCP, as GCP has latest features and a lot of new tech that is coming into this to add to the piece of enhancing data performance, give out inputs on a very real-time basis. One of the primary focus of our whole today's talk is about de-siloing our data. So what does this actually mean is like, let's suppose there are different modules that are present. So there's HR module, there's a production module, and when these tables or these silos are growing apart in their own manner, and the connectivity from these two silos is actually getting problematic when we look at the future of this. So de-siloing your data is very primarily focused. And the next approach what we are going to suggest, or like how to look at it, would be one approach is a data fabric. Next approach I'm going to speak about is data mesh. Even before jumping into it, how do I look at data fabric is like how into the earlier days of data warehousing we used to look at this as a bill in one approach of a top down or a bottom up. So we can look at a data fabric as a top-down approach, where we already have a lot of modules, lot of operationalized departments already working interconnectively, but this needs to be fabricated into a complete single framework. You can even look at this as a data fabric thing. If you're a physics fan, I would say the fabric of universe, what it says is that the rules across any point of the fabric applies the same. So speaking in terms of that angle or aspect, this is the similar implementation. What a data fabric is basically a concept where all the silos or modules which we have is fabricated into or integrated into a single layer. The data democratization is the key access. When we mean data democratization is like to access for a person, to access at the right time, the right method, and the right consumer. So the right data consumer needs to access at the right time in the right method. When this seamless process happens all throughout the process, then a successful data fabric need is what we said we have implemented. The whole technology beneath it sits the same. Two more pieces that goes along with technology is processes and people. When these all three are aligned, then there is a use case of a successful data fabric or a data mesh that can be come out of it. Now let me just elaborate this on how it works, and like with the help of a quick example. Let's suppose say you are an insurance provider, and a client has just got into an accident, and he has clicked a photos of his car and he has uploaded to our system, and he to quickly expedite the process and get his reimbursement, he has called you up to your system, and one of your operators has picked the call, and he's tried to process like what has happened and how do I process. So in a normal terms, in terms of when data fabric is not implemented, the boxes or pieces that the operator has to fix are immense. A lot of visibility is not present to the operator. Now let's suppose the same thing is applied with the help of a data fabric. So now if you see in a typical insurance setup, if you see there are a lot of documents that is being processed, a lot of images along with the hierarchical or the traditional structured data as well. Now, when we put everything into a single framework or a fabric, the modules are working differently, but access to the operator across these modules is something that is seamless. And when the operator accesses the data fabric, he or she is able to access the complete information. So he can just right away pull up the images linked to whatever AI/ML is running behind predicting the claim that is to be a fault or not a fault. Along with it, it can actually see the previous claims, the history, and everything, the trends going on in a real-time basis, and can actually help the customer going in a seamless manner. So this complete structure, if we see, so the one way to take approach is to talk about a centralized view, like bringing all the data together. Now the problem with that approach is like there will be a lot of governance issues, a lot of security issues, a lot of compliance check that needs to be checked. This can tackled with the very easily with the help of a data fabric. Like the modules, the silos are placed differently. Each one is operating differently in terms of their with respect to their security, governance, and compliance. Although with respect to that also, it is able to seamlessly, a person is able to seamlessly access all throughout the information. So the whole philosophy of a data fabric lies that the right data consumer gets the right data method at the right time. That's the whole idea of a data fabric, which we look from a top-down approach. Uh, and moving on to next is till now what we have seen is a lot of centralization around bringing data together. So in the late 1980s, when the concept of warehouse was built, then we moved to 20s where we saw the data lakes emerging, then cloud platform, the whole even the data lake house, which is the recent talk of the market. Everything you see over here, the core concept is like the data is they are trying to bring into a centralized manner, a centralized place, and then they are trying to access it, then they are trying to modify it. So there are a lot of issues with this because there is a lot of varied data sources, there are a lot of varied data types, there are a lot of issues with maintaining this kind of data. There is a lot of data replication, a lot of these issues when put on together come to a standstill of these technologies not growing ahead in terms of that. But now what we have seen new emerging technologies about data mesh, and data mesh completely talks about decentralization of these modules. When I say decentralization of this module, let's suppose say there are multiple modules or silos in our HR, and let's suppose the HR module looks not only is a data provider, but it also owns the domain data behind it. So the whole concept of a data mesh revolves around data domain and the ownership of domain. So to give a quick overview of this, like is an intentionally designed distributed data architecture to not get cluttered or under working different domains working under their own ownership, but still there is a centralized governance across all these silos, across all these modules, and standardization of interoperability is one of the key aspects that data mesh has brought us when we talk about as an aspect. So primarily data mesh works on these four principles. So first is ownership, and there is a lot of emphasis on this because decentralization and distribution responsibility of people. So HR people would be owning the data under their HR module. The production people would be owning and maintaining their module, the data generated under their module. Now, when these different silos are put together, data mesh actually is able to decentralize the working, as well as now it has defined a central governance as well as interoperability. That is where this brings the real idea above rest of the ideas of implementing this. Second principle is of data as a product. A lot of our companies these days look data as a byproduct, but we need to change this perspective. Like the data needs to be the one of the products that we are generating these days. So how does data as a product work under a data mesh is like the domain data, typical domains or silos that are there. These are the products, and whoever are the consumers would be the customers, and we would be treating from the domain data product owners to different customers as their consumers. There could be different data admins, there could be different data guardians along the whole process, but the whole idea revolves around data domain product owners and consumers. Third is self-serve data infrastructure as a platform. So earlier, a lot of emphasis on the whole data engineering team, data science team was sitting between the data provider, data sources, and the analytics or reporting part. They were the ones swinging between them, and they were primarily focusing on building the pipelines, building, keeping generating reports, and all this relevant task on a data engineering on a day-to-day basis. Now this idea new silo or a new domain wants to get onboarded on this, they can easily go on a self-service kind of option, and they can quickly build up their domain. So the whole liability or the whole focus moves right from setting up everything to just for focusing on their own domain or bringing up their own silo. Stands out data mesh with respect to all other concepts is of federated computational governance. So the idea is like globally there is the standards of interoperability across silos across the whole data organization, but locally there's still an autonomy. So the HR folks are still focusing on their how do they process data, how they can still the process of a HR can differently vary from a that made of a production guy. So in terms of they can have a complete, let's suppose, say Python scripts, then they can use any data warehousing tool like Snowflake, and then they can process into CSV file or Excel file. Whereas on production level data, they can completely move to SQL along with any other cloud players like GCP. And still the process, the local autonomy is still there for these two processes, but still they are interwoven globally for this interoperability. So this is the whole idea of data mesh that is working around, and how keeping the whole idea is also moving around on the piece of not to move data around, instead keeping the data as it is and building services around it. The primary aspect is increasing the connectivity among the silos or modules is the primary focus of data mesh, which has been really well accepted by companies or enterprises these days. And lastly, I would just like to focus on a case study where we have actually implemented intelligent data fabric using Dataplex. So this is for Deutsche Bank, and to give a feel of like it works globally, and it has almost 1.4 trillion assets. There are 84,000 plus staff working around 2,000 branches, around working around 50 plus countries, with hundreds of petabytes of data being processed on a daily basis. John, the head of big data analytics at Deutsche Bank, mentions that before and after implementing a data fabric, how his aspect changed, and how the learning journey has been for him in terms of the lessons that they have learned is like primarily like treat data as an asset, as we were even Kirthi was mentioning, and we were also mentioning in terms of treating data as a product instead of a byproduct. So that's where whole alignment of our whole ideology works upon. Codify regulation, automate process, and embed controls. When we have implemented a data fabric or a data mesh to this level, the amount of automation that we can generate out of this in terms of even regulation, governance is immense. The sky is the limit on this piece. The idea is again one of the core problems we have seen in failure of data lakes or a stop point of data lakes, where there was a big gap between operation and analytics. So a lot of problems were faced on a day-to-day basis by a data engineering team with respect to the data analytics that required some of the stuff. So these gap was completely closed with interweaving of all these silos all across together. And last but not the least was an over reliance upon centralization. So all across for previous all these decades, what we have been totally focusing on our centralization pieces, like bringing a lot of data together and then trying to process and figure it out, like how do we work upon it. Instead, the new approach would be like to keep the data silos around, let autonomy flow in their own silos and modules, and then we can speak on standardizing, centralizing the whole governance and connectivity among this silos. So that was it on the whole approach of how the concepts of data mesh, data fabrics is there, and how we can leverage Dataplex as well as Big Lake to implement these concepts and look at the future as an aspect in terms of like how at the rate at which the data is growing, we need to also keep that in account, how to handle and deal around all these pain points that we have seen, and the hierarchical or traditional methods won't be working for us, and we need to adapt to these new technologies. And hope I wish that you found this useful in terms of the future of analytics, where this is going, and like how you can adapt to this journey. You can definitely reach out to us in terms of any other details you are required. A big thank you from the Google team and Niveus team to all of us who have joined, and maybe we can take up questions.
Thank you very much, Mr. Thorat and Ms. Ganapathy, for that truly informative session. We move now to our Q&A section, and we seem to have a good number of questions from our audiences. However, due to paucity of time, we'll just take a couple. So the first question is for you, Aditya. It says, what is the difference between data mesh and data fabric?
Okay, look at this at a way in terms of if your organization or enterprise comes from a very data oriented perspective, and if you want to go a top down approach or a bottom up approach. So what is happening in data mesh is like you are defining the autonomy of all the silos, and then you are trying to fabricate or build stuff on that. On the other hand, on the data fabric, you already have a lot of pieces, silos we are put together, and you're trying to put a fabric on that and to increase the connectivity among them is what the primary difference is. But still, I would suggest to look at this from, if you're a data oriented company, look through the window of a data mesh. If you are more of focusing on other aspect, then you can focus on the data fabric methodologies.
Thank you, Aditya. The next question is, how can Dataplex implement a data mesh architecture? Kirthi, would you like to take that?
Sure, and I'll take that. So essentially, I think Aditya gave good pointers around what a data mesh architecture is, right? So data mesh, essentially, as you know, it's about logically organizing your data depending on how it is used rather than where it is stored, right? So he gave examples. So when we look at the example and say talk about different data zones such as product, operations, and sales, for example, you will still need an underlying data fabric that acts as the unified data management and governance layer. And that is the one that actually helps in supporting consumers and catering to each consumer's unique needs and styles of data analysis and processing, thus offering a unified experience, right? So while BigQuery and Google Cloud Storage actually serve as the infrastructure to store and process data, Dataplex is the one that provides that single pane of glass to organize, govern, and index data in the data mesh. So Dataplex provides a managed service that enables enterprise to group data containers across their Google Cloud deployment and organize them in a hierarchy, effectively overlaying a data mesh virtually on top of the Google Cloud project hierarchy, with zones representing different data domains in the data mesh. You can also curate, catalog, secure, integrate, and explore any type of data at any scale with an integrated experience. To support building a data mesh, Dataplex also enables quickly built lakes without needing to acquire and worry about different resources. It also enables automatic data discovery and schema inference across different systems as well. So once you add a resource to Dataplex, it can actually be represented as part of the data mesh as well. So if we were to look at examples on this, using the same, sales data, say for instance, sales data, CRM data, and products data. Now, each of these are actually going to be implemented as a different data lake in the data mesh architecture. Each of them will have their own respective data pipelines, enabling the respective product teams to set up very fine-grained permission control as well, including at the zone level on each one independently. Now, as defined by the organization best practices, these products can then be versioned, documented, and published on the data catalog to ensure discoverability and usability. So, for instance, if there is a different team that wants sales data, they could actually ask for the sales data only, and the sales data which is actually published on the catalog can then be provided to the different teams as well, so that all of this data can be consumed and leveraged by any other data product using standard published interfaces such as APIs and datasets. Similarly, the data science team can also request for and gain access to the data they want and process it in their own notebooks and tooling. Similarly, you can also have the visualization team using the visualization engine of their choice, and similarly pick up different data depending on how they are published in the data catalog and use it the way they want. So this essentially is how a Dataplex can support a data mesh architecture.
Lovely. Thank you, Kirthi, and thank you, Aditya, for answering those questions. We're really out of time. We would have wanted to take more, but we'll ensure we answer the rest of the questions offline. So with this, we bring today's virtual conference to an end. Today's session would not have been possible without the active participation of all our esteemed panelists and delegates. I would like to thank each one of you for taking your time out and being a part of this virtual conference today. A special thanks goes out to Niveus Solutions and Google Cloud for their support to this initiative, without whom this conference would not have been a success. Thank you once again, ladies and gentlemen. It was great to be in your company this afternoon. Have a wonderful day ahead. Take care and stay safe.